Everybody, in this video we're talking about similar polygons, and we're going to be finding sides and angles using these similarity statements. Now these similarity statements work for all kinds of polygons. Now we're going to be mainly focused on triangles here, but just know if you have a 4 or 5 sided shape, it's going to work just as well. And before we get into the similarity statements, I want to make sure that you are that you know the difference between congruent and similar. So remember, congruent means that we have the same size and shape when we're talking about two figures. That means that the corresponding angles are going to be congruent. That's what holds the shape. And the corresponding sides are going to be congruent, just like we see in these two triangles ABC and DEF. And because those are congruent, we can write this congruency statement. And when we're dealing with similar figures, they have the same shape, but they're a different size. And because they have the same shape, though, the corresponding angles are still congruent to each other, because that's what holds the shape. But when we look at the sides, then they're not going to be the same length anymore, but they are going to be proportional. That means when we compare the lengths of the sides, the corresponding sides, and we put them all in ratios, which we'll see here in just a minute, then those ratios have to be the same. And of course, we can write a similarity statement, and notice how it looks very much like the congruency statement, except our symbol is a little bit different. Now let's talk about these similarity statements. Remember, just like in a congruency statement that we dealt with last unit, the order matters. When we're naming those triangles, that order tells us something, and it tells us which parts correspond to each other. So when we look and we want to find all those corresponding angles, well, we just look at the name. Since A is first and D is first in each one of those names of the triangles, then A and D have to be congruent angles. B and E, they're the second in the name. C and F, they're third in the name. Those correspond to each other, which, and again, with similar figures, those will be congruent. And just like what we did with the congruency statements too, we can put any two letters together to represent sides, at least in these triangles. So we could look at the first two letters A, B, and D, E of those respective triangles. So those sides correspond to each other. B, C, and E, F correspond to each other. And then we can see the last sides A, C, and D, F correspond to each other. And because these are similar, then the ratios of those corresponding parts have to be equal to each other. So if we knew what those side lengths were, then those ratios would be exactly the same. And because of that, we're going to use these similarity statements and proportionality and all that. We're going to solve for some missing information. So here we're going to use the similarity statement given to us that triangle ABC and triangle DEF are similar to solve for some missing angles and then solve for an x. We see angle F is listed, given to us as a 2x plus 5 measure. And so we're going to have to eventually solve for x. But we need to put all the parts together. Remember, the order matters. A and D, since they're first in the names, those are going to be congruent. So if A is 80 degrees, then angle D will be 80 degrees. We know B and E have to be congruent to each other. So if E is 45 degrees, then angle B will also be 45 degrees. And then to find the other angles, angle C and angle F, we know angle F is given to us at 2x plus 5. But remember, in a triangle, of course, everything adds up to 180 degrees. The angles do. So if we take the 80 and the 45 and add it together, then we can find angle C, which would be 55 degrees. And then to solve for x, because I know C and F are the same angle essentially, I just make an equation out of that. So that 2x plus 5 then has to equal that 55 degree measure. And then we solve from there. Subtract 5 from both sides, then we'll divide, and we find out that x is equal to 25. Okay. Now to use it for sides, it's a little bit more complicated, but again, if we can pick out the corresponding parts using that similarity statement, again, remember that order matters there, we can figure out what we have to work with here. So you'll notice here in that triangle ABC that we've got the measure of all the sides there, and we're going to be trying to solve for this measure of E to F, which we've labeled as x. So we have to look and see what we've got. We've got this D to E length of 15. And we'll notice that since D to E is first and second in the name, of that triangle, and when we look at the first triangle, AB is listed first, so those parts have to correspond to each other. So AB and that DE represent the corresponding sides, and so we can put that in a ratio, and we can compare, and then we can figure out what X is, because if E to F is second and third in the name, I know it's going to compare to BC. So we have to use BC in order to find E to F. So we can put these as a proportion then, and now we can solve given what we know. Okay, we know AB is 5, we know DE is 15. We can just kind of substitute that into our first ratio. And then we can sub in what we know for the second ratio. And if BC is 7, and we can just label EF as X, now we've got something that we can use to solve. Now, most of you are probably pretty familiar with the cross multiplication method. You take the bottom left and top right, multiply it together, the top left and bottom right, multiply it together, and those will be equal. So in this case, that 15 times 7 is going to equal the 5 times X. So we have 5X then is equal to 105. And then to solve for X, all we have to do is divide by 5 on both sides. And that length of E to F, or X, is 21. Now you may also notice a pattern here in the ratios. That 5 to 15, notice that the top number is a third of the bottom number, or that bottom number is 3 times as much as that top number. Well, that's your scale factor. So you can always use the scale factor here too. So if we take that AB of 5 and we multiply that by 3 to get to 15, then all of those smaller sides have to be multiplied by 3. Okay, so if we take that 7 then and we multiply that by 3, we find out the same thing, that EF is equal to 21. And then if we needed to solve for that last side, we can do exactly the same thing, multiply the 4 by 3, which would give us 12.